Okay, so yeah, hi everyone. I'm Peter. This is Fabio, and I can't seem to. Oh, my video's off, right? No, my video's on.
Video's on.
Okay, people can see me. Okay, great. So today we're going to do a little bit of an update and then some just Q&A, friendly Q&A for people here in the Austin community. So how many people here have heard of PyScript? Okay, a few. Great. So this will be really good. I will do a very, very short kind of recap of sort of my talk that I gave at PyCon in April, at the end of April, announcing the PyScript project, and this will give people, a sense of what it's about. And then I'm going to go through some other topics about kind of what we've done since then and kind of people's reception and things like that. So to start with, if we think about what's great about Python, there's a lot of attributes. Can you guys see that on the screen? You can, right? There's a lot of attributes which I think are people generally agree with it about, like, okay, it's easy to learn. You can learn just enough that'll fit in your head, and you can do many different kinds of things. It does many kinds of things with modest effort, which cannot be said of a lot of languages. Some languages can only be used for really certain specific things. Python can be used for just about everything. And also it's very popular. By some counts, it is the world's most popular language. It's certainly one of the fastest growing languages because it's useful for data and data analysis and AI and ML and all these things. And one of the reasons it's popular for that is because the Python runtime, the CPython interpreter, has these low-level extension mechanisms that allow you to build bindings to very, very fast libraries, and you can leverage those libraries. And that's really what made it popular for numerical computing, for science and things like that. And that then from that community grew the machine learning and the AI usages of Python. The problem is that the browser has really won the not the problem, but one observation is that when we talk about the OS wars, right? Many years ago, there was such thing as an OS war. Like, people actually cared what operating system you're on, because fundamentally a lot of applications wouldn't work between different operating systems. Now everything runs in the browser, with a small fraction of things really needing to be native on the desktop. So the browser definitely won the OS wars. The browser is the most widely deployed operating system, operating environment, user interface in the world. But the only language that it supports is JavaScript, really. Like, it's JavaScript or something that compiles to JavaScript, like a TypeScript or CoffeeScript and things like that. But what happened is that WebAssembly has really changed the game. And for those of you who are not familiar, a few years ago, this became a standard, but even a few years prior to that, what people realized was that the browser only runs JavaScript, but there's a really capable runtime there in the browser. And if we could abstract the interface between the high-level JavaScript parts and the low-level browser machinery, then we can make this virtual machine inside the browser exposed to many different kinds of things. And so WebAssembly is the assembly language, the instruction set over the virtual machine that runs inside every single one of your browser tabs. And that virtual machine, you can think of it like a virtual CPU. Okay, so WebAssembly is a instruction set like x86, and it runs on that virtual CPU that runs on in your browser tabs. And so it's actually quite powerful. And furthermore, a really interesting capability has come around where, this project called Mscripton, it actually takes that CPU and builds a POSIX compliant layer around it, so you can compile many C and C++ codes to run on that CPU. It's actually an incredible thing. So people have ported all sorts of stuff to run on the browser on WebAssembly, including, oh, by the way, it does run everywhere. So it's not just like a weird cutting edge thing in the latest Chrome or latest Edge. It actually is very widely deployed, even on mobile, even in international operating systems, mobile operating systems. It's quite popular. And the Python interpreter itself just recently announced, the Python core team, they're going to support WASM, or WebAssembly, as a native sort of CPU architecture in Python. That's really cool. So what PyScript is PyScript is a framework for creating rich Python applications directly in the browser. And that includes the entire Python numerical ecosystem. Not the entire, but a lot of it. So the standard things like scikit-learn, NumPy, pandas, matplotlib, all the things you're used to, all of those things have been compiled down to run on this WebAssembly virtual CPU. All of this runs inside the browser tab. And so you can, with PyScript, you can interleave Python code with HTML, just like PHP whether it's a good thing or bad thing, we'll talk about. But when you write that Python code, it's also not just in its own little island. It's actually fully able to communicate to the JavaScript code running in the browser tab. It's also able to communicate with the DOM, and it's able to look at things in the DOM and do all these things back and forth. So it's really very interesting, because what this means now is that your Python deployment story isn't to learn PyInstaller and Py to app and Py to exe or roll a Docker container. Your deployment story is to email somebody an HTML file. And that HTML file has inside it a py-script tag and then their Python code. And imports and libraries all come into that thing. So you're really treating every browser tab on just about every single mobile and desktop on the planet as a virtual machine that you can deploy Python code embedded in HTML to. That's very, very, it's a game changer. You don't actually need a web server, to be very clear. This is entirely an in-browser technology. It does not require you to run a Django server or a thing, or it's not serverless like running on some functions in the cloud. No cloud involved. You could do this off a USB stick. So this is what a simple script looks like. Some of you may think it's an abomination. Some of you may think it's an April Fool's joke, but it actually works. So one of our design targets when we were first thinking about this and we realized this was a possibility, besides, wow, that's kind of weird, it's kind of messed up, our thinking was, what would be very interesting is you could tell anybody on the planet that has a working web browser and a text editor, you can say, type this code into the text editor, double click on it, it opens up in the browser, and you actually have a working Python app. That's your deployment. Right. So this is very interesting. You can, you see here, we can import the datetime module. You can call a function there. You can then call a, you can return a value, and that value then gets displayed in the DOM. And so I actually don't have the demo in here, but we have some examples, and Fabio will show some demos in just a minute. But the way this actually works is that we have, as I mentioned, we've compiled, we've taken the compiled version of CPython and a lot of the numerical libraries. That's all part of a project called Pyodide, so really leveraging their heavy lifting on that backend part of it. But then PyScript itself is a lot of stuff in the front that is very opinionated about how it loads things, how it interprets the code inside the brackets and everything. And so that's the PyScript layer. Underneath, all of that, of course, is the WebAssembly thing itself. And so just to again run, just to reiterate, this runs truly serverless, no purely client side, and you can of course run it on a server if you want. But if someone hits your web server, they're downloading your PyScript, code in the HTML, and it's running in the browser tab, not running on your server. So your server process is literally just like a FTP server. You do this on a CDN. So some demos. If you go to PyScript.net, you can see some of the demos running, and it's very nice. It's very easy to see the stuff running, including a REPL. So what we have here is you can embed this widget called the Pyreple, and that essentially lets you click, type code in, click, type code in, click, and it just runs Python right there inside the browser tab. This is not Jupyter, and this shows that you don't really need all of Jupyter if you just want an embedded REPL inside your HTML, inside your web page. So also, all the output just shows up in the DOM. So you can just output HTML, and that will show up inline in the DOM. It's very, very extensible, very flexible. So what the project is not, it is not just serverless Jupyter. There's a project called Jupyter Lite, which uses the same Pyodide infrastructure, I think, right? Mm-hmm. Yeah, it still does. And this is also not just about cramming all of like the SciPy and PyData stuff into the browser runtime, because that's a lot. You might as well at that point just download Anaconda and just run it locally, right? This also isn't just like Python as a JavaScript replacement. What this actually does is Python as a JavaScript replacement, but also removing the need to create client-server applications by default, right? For the last 20 years, all of our application development in the browser and the web, a lot of modern stuff, it's all fundamentally client-server. You have to write client-server code, even when you don't really want to, right? And so this makes it possible for you to write Python code just like you would write a Python script, share it with someone. You have full access to JavaScript, to D3. We have some examples showing Python wrapping D3. We did that in about 2 days, right? It was actually very simple if you can run Python alongside the JavaScript. For 10, 15 years now, we've wanted to have a D3 wrapper in Python, and the good one has never really fully emerged. Now with PyScript, you can just run Python alongside literally D3 in the browser, and it's very easy to wrap. So this is really about taking advantage of the web browser as a new green kind of greenfield white space thing, using it as a ubiquitous virtual machine, and making Python the preferred runtime in there, not JavaScript. So that's a little bit of the thing. So do we want to switch to Fabio? You want to show a couple of demos?
Yeah.
I will stop sharing, and I will also mute myself.
All right. So the web page, as Peter said, is PyScript.net, showing just where you can find the examples, and you can find the examples here. I will start. Since Peter talked about the REPL, let's show the REPL how it works, and not this one. This one. So let's start with who's familiar with
Command plus, make it a little bit bigger.
Yes. All right. Actually, like this. Who's familiar with the import anti-gravity module in Python? It's a module out of the famous comic about, import anti-gravity, etc., etc. But we have a custom version for PyScript, and this one you can actually make it. Real-time debugging. You can actually make it fly, and it's not an image, static image, or GIF. It's actually basically changing the SVG and manipulating in real time, running on the browser. Other things you can do, as Peter said, if you just print hello, we'll just print whatever you type in there. And as you can see, depending on the output that you have, if it's just text or things like this, just type it outputs that. If it has the right MIME types, etc., it becomes a real object in the DOM, like an image and things like that. This is a way more complex example, running a stream of data on the browser and displaying things with Panel, which is a visualization library with widgets for Python on the browser. This works with Python directly on your local machine, but there's a port of this to run just with PyScript on the browser itself. Let me move this out of the way. This one is an example of actually using D3 in Python. We have side-by-side a JavaScript version and a Python version. And let me show the code for this. Make it a little bigger. And as you can see, well, it's a little too big. The Python code in here, this is the JavaScript code. And that's Python code. And this below is Python code. And you can see it's pretty similar. There's no it's more Pythonic, of course, it's using Python stuff, but it's not using drastically weird things. It's just like using the same methods and the same things that you would do in JavaScript. Getting back to other examples, this one, the DeckGL example is showing New York taxi data over a period of time, showing, I think it's rides and number of rides over time, and you can interact with the objects. It's using DeckGL inside panel, and you can interact with the widgets and things like that. Show different times of day. You can actually run scripted animations, backed by Python, etc. And the cool thing about this is if you actually have, if you add the REPL to the page, you can actually directly interact with the objects that you have. This app is actually called App, I think. And if you type it in the REPL, it shows you this is the app object, etc., etc. If you do app dot, oh, cool. You do like app radius equals 75. We can change the radius in real time. And the data frame, I think, is df. So if I do app dot view equals df, it changes the data set, in real time. Things like this. It becomes really interactive, and it's a way to basically bring Python directly to the developers and users without all the annoyances of having to install Python, configure it, install your dependencies, everything. Everything is isolated. Is there any other demo that you wanted to show? Or I also have a few.
WebGL one, right?
Oh, yes. I think I actually had it open before.
Oh, yeah, you have it open, right?
Yeah, this one is basically showing interaction over WebGL, using directly WebGL from the JavaScript side through proxies, but in Python.
Actually, if you hit F12 on this, right? You could look at the source code as well. Like the source code on the browser just shows the Python.
Let me see. Oh, sorry. Oh, actually, you can't see the code because we hide it. Yes.
Oh, okay.
This is the code for this. WebGL, index HTML, and then basically this is the code. We are basically instantiating the JavaScript objects and all of that in Python, and then running, doing the computation in Python. And for everything that we pass the objects to the JavaScript objects from, we pass everything from Python to JavaScript and back and forth. All right. A few things that I wanted to show from, not that we did in the examples, but they came from the community. One that is pretty cool. Someone did, Dylan did this basically cheat sheet. Actually, I wanted to show this first. Pandas cheat sheet in PyScript, so you can just visit the website and play with it, learn pandas, etc., directly there in the browser. And you can do things like this: choose an operation, yada yada yada. It will change, and you can interact with it. Eventually, type your things in here. Blah blah blah. But even more cool. He also created a cookbook for a data viz cookbook directly in PyScript. So if you want to learn pandas and you want to draw a line chart, you can run the example, or let's say a scatter plot.
It's worth reminding that none of this uses a server.
Right.
Hosting costs are minimal.
Yes. Or none, right? Like if I think he's hosting on GitHub pages or etc. Right. So it's really, as you said, minimal. Let's see, histogram. There you go. A few other things from folks in the community. Well, this is the cheat sheet cookbook. This is a port of a project to PyScript running directly on the browser. Pretty cool. This is actually a project that someone was doing on embedded device to run a game in there, and basically took just like little time, a few hours, to actually re-implement it in PyScript. I think he had a demo or something. Well, I can't find it. Another example, or porting, this one is rich textualize in PyScript. So those things is basically generating a table that would run in the console, but with PyScript, it can run basically in the browser directly with the same effects of the console. That's pretty much it that I have for examples. Sure.
Great. Okay, and so I have just a couple more I guess a little bit more slides here. So anyway, the recap here is everything that you saw, all the examples you saw, remember there's no server involved. It's running, and it's also not taking the Python and compiling it to JavaScript or anything. It's taking the Python and running it on the actual CPython virtual machine, which all of you run, when you're normally running Python. That virtual machine has simply been compiled to run on this architecture that is the browser virtual machine. So I just really want to make that clear. It's a little bit of you have to wrap your head around a little bit, but it's pretty performant. I think there's some, it's not as performant as the native when you just run the Python interpreter, but it's not bad. It's not too far off. And the lack of having to worry about the complexity of install and distributing on someone's target environment and set up this virtual env or do that con install, that saves everyone a lot of headache and time, right? So zero install runs everywhere. We announced this at the end of April at PyCon. And then in the last 4 months, we've managed to hire up a full team to work on PyScript open source. We're also working on some other really cool things that we're looking forward to revealing over the next few months. We're also adding local backend. So one of the big problems with PyScript right now is that it does load pyodide, which is pretty hefty. It's, 25 megs, something like that.
Compressed.
6.
Yeah.
Right, but then like if you start pulling in these other packages and everything, the load time is the thing that everyone kvetches about. But with MicroPython, with an alternative Python interpreter, we can make that much smaller and lighter, where it loads very fast. And now you have no excuse to not be writing Python in your HTML, right? We're also working with a broader community of folks who are interested in the Python and WebAssembly story on, okay, how are we actually going to distribute modules? How do we make this not into a complete disaster? And whatnot. So that's a bunch of work there. A lot of API cleanups and API design kind of things. So it's a very active project. A lot of fun things going on. We have actually two of our newest devs right here, and actually our dev manager Ted. And so the last 4 months we did all that stuff, and also we got a lot of feedback as the project comes up every now and then on Twitter and Hacker News, and the feedback was not always positive, right? There were a lot of people who didn't understand why we did it. A lot of people who thought this was for sure going to be a bunch of security nightmares. A lot of people said, why don't you just learn JavaScript and all these things? So it's, even when you release something that you think is awesome, Hacker News will find ways to make it sound not so awesome. But on the security thing, I just want to reiterate, because this is running within the browser tab sandbox, that stuff is engineered very, very well. And that stuff is pretty, PyScript is no more insecure than JavaScript running inside the browser tab. So if there's a security problem, then everyone from Gmail to Amazon has a problem as well, because you're running inside the security enclave of the browser tab. I'm not going to answer any questions about Rust. But the big question I will answer is why. People are like, why did you do this? Because this is, okay, interesting academically, maybe it could even be useful, but why did you do it? And fundamentally, my motivation is to further democratize the access to computing, especially when it comes to accessing data, doing things like data manipulation and machine learning and AI and these things. Getting those things installed correctly, getting things reproducible is very non-trivial when it comes to this stuff. Even though Python is a very accessible language, even though we've had very much success teaching it to lots of people, including children, it's still, when you actually go to do things for real, the infrastructure piece is the hard part. The language itself you can learn in an afternoon, but the infrastructure pieces will take you years, and even then you're still stubbing your toe on stuff. So a thing I like to point out to people is the number of programmers in the world, by conservative estimate, is like the blue squares there, and the population of the world is the rest of the squares there. So just to give you a sense of how much work we have to do, right? Because my personal belief is that we have a computer literacy problem, and we've constantly had this, and now with AI and ML, we're going to have this even worse, because the impact of computing isn't just taking your Amazon order or letting you check an email thing. This is actually going to be making policy decisions. This is actually going to be going and allocating all sorts of things, people's credit, and all these other kinds of things. And more people need to understand how this actually works. Inspirational quote from the Boston Public Library. Really, so we pitch it as PyScript is programming for the 99%. So all the other people out there who are too intimidated by it, who get frustrated by programming right now, we want this to be children's first introduction to programming. We want this to be a way for children to make interesting things and share with their friends. Quirky things, goofy things. Kind of that old, the old school web before it got all like crappy and corporate and attention economy. Like the web was a really fun, quirky place with people making all sorts of random things. So we really want that hackability again, right? You really can't go and look at the source code for a modern web page and make heads or tails of it unless you're an expert programmer. We want this to be readable. We want people to be able to look at other people's PyScript things and then hack on it and make cool things and remix. So also, I'll just kind of drop this to whet people's appetite. With WebAssembly, we've actually achieved what back in the day they wanted to do with Java. We actually have a virtual machine. Microsoft, so the Sun tried to do it with JVM and Java. Microsoft tried to do this with the CLR, the DLR runtimes underneath C#. But we actually now have a portable language and somewhat of a runtime environment and a whole front end, all the richness of JavaScript, HTML, CSS, all of this is available now. And so the browser tab is the environment, the portable environment that we've always wanted. It's just programming it really sucks if you have to learn a whole bunch of HTML and JavaScript and deploy it on a client server architecture. If you could strip away a lot of that complexity, take a simple language like Python, write a simple little app, put it on a USB stick, give it to a friend, and they could just run it. You just completely restore this portability and this peer-to-peer nature of the original personal computing era. And so one strategy for decentralization is not to sell JPEGs with NFTs, but rather just to remove the need to centralize things for distributing applications. So this is one of the things, the subtle things that we're quietly trying to work with people on, trying to find collaborators on, and there's definitely a lot of interested parties in this. So we're looking, thinking somewhat about how we can do some of these things as well and put those primitives on here. So anyway, that's okay. That was the demo of that Fabios Show. That's all right. It's good. So anyway, yeah. So with that, are there any questions, comments?
One
more thing.
Things to say.
Microphone is here.
Awesome. A couple of things that I wanted to highlight are that to those statements like we already have JavaScript, why do we need this, et cetera, et cetera. I really want to highlight that this is an additive project, right? Like it's not a competing PyScript or JavaScript. Right now the loading time is a lot, but you can't really run models with JavaScript. You can't really do a lot of the scientific plotting. You can use NumPy or pandas and things like this. I would rather, you can now use PyData and PyScript to use that in JavaScript as well and do some scientific computing in JavaScript if you want, if that's your language, etc. And from the Python side as well, like we can now have access to things like D3 and other libraries that we've been dreaming about. And so it's really not about competing, but collaboration. Hopefully language will not matter that much, at some point.
Well, people will still need a language.
Right.
And with this, it'll probably be Python.
Exactly.
Yeah, don't tell anyone.
Yeah.
Secret plans. All the arguments about, well, we have JavaScript, why do you need Python? You can make those same arguments 20 years ago. We have C++, why do you need Python? And I can guarantee you, if every single AI/ML researcher needed to write C++ to get their jobs done, you would not have a lot of AI/ML right now, right? So there's absolutely an argument, a data point we can look at, a very substantive data point about why it mattered that we put a more accessible layer on top of the computing infrastructure that existed at the time. And so we're just sort of doing that same thing again. And I think it's very thematically, it fits. That's the Python community, and it's the numerical Python community to some extent that is doing this once again. So anyway, any questions? That wasn't actually a question. Yeah. Any questions? Any questions on the chat here? None. Stunned silence.
So it supports WebSockets as well.
Great question. Yes.
The question was, does it support WebSockets?
WebSockets, yes, it doesn't support sockets, right? So actually a few things to remark. Python on the browser is just a little different than Python on your local machine, etc. Mostly because a few things are different. The file system is different. The sockets are different. There are no sockets there. WebSockets, they are similar, but they're not the same. Everything multiprocessing or multi-threading, etc., will not work because it runs on the main JavaScript thread. that's the problem that as the Python community we're looking at, and the solution, I think it's pretty clear for us, which is just we need to run things in web workers, and then we can have access to a lot of things. So this is the solution is underway. I think those are the main differences, to be honest.
Most of the web primitives are accessible, so
Mhm.
anything, any API that's in the browser, you can get to.
Yeah.
Right. The 3D, the OpenGL demo, that was using Three.js. It was just a simple wrapper around Three.js and directly calling the functions there. So you had the question, yeah.
So if I compare this to how JavaScript applications are built, front-end JavaScript application, you have this Webpack sort of build process that gets all your dependencies and puts together in packages that are then, you've got Treeshaking involved in all of this that gets then delivered to the front end. How is that, if we wanted to have a Python application sit side by side or within or whatever a JavaScript application, do those dependencies get factored in? How does that deployment happen? Is there tree shaking? That sort of stuff. Does that make sense?
Yeah, so the question, I'll repeat the question for the online audience. So the question was, in the JavaScript world, when you build these applications, there's a build step and a packing step, right? That does a lot of stuff. And so if you have PyScript code alongside that JavaScript, how does that get factored into it, right? How does that play with that ecosystem of tools?
Right. So that's a great question. Right now, there is no packaging step, right? But also it's very early in the life cycle of PyScript, and it's not really just a PyScript problem, it's a Python on the browser problem. You know, right now we get the whole interpreter with all the batteries included. Those batteries are actually also expensive, plus everything that you install on top of it. So the PyData project is actually looking into this. They just started a project called a PyData Pack or something like this, where you can actually package things. There are other projects also working on this. Mscript and Forge is another one that basically sits on top of PyData and allows you to install packages sort of in a Anaconda format, and you can create an environment that becomes the thing that you load. All of those are not doing tree shaking as we would like, but we're discussing things like, you know, tree shaking full modules, or also if you're using just a third of NumPy, can we do somehow tree shake that side of things and make it work faster? Another thing that, you know, that is in play too is, can we use web technology to make things faster anyway? So if you already loaded a bunch of modules in your browser, and they're in your browser cache, can you reuse that? Or can we use progressive web applications to just package your stuff and you can distribute it as an application on your local machine or your mobile and stuff like that? So all of that is part of the conversations that we're having with the community, but also it's I don't know, 1 year. Well, PyData project is a little older, but it's really young in terms of technology and Python, you know.
Yeah, but speaking of the PWA thing, it does work on mobile now. So
Right.
It totally works on mobile. You can actually save PyScript apps to your homepage, and just like any other progressive web app will load. It'll look like a native app on your like iPad or something.
And that actually is a good point that we didn't highlight enough. Like there was basically, I wouldn't say no way, but really difficult for you to run Python on mobile, right? Like it's tough. One of the projects trying to tackle this, Beware, that we've been funding actually, it goes through a lot of really bad hairy scenarios of having to package your Python application, go through you know, whatever app store you need to use to install things in your mobile, stuff like that. Like with this type of technology, it really becomes, you know, immediate the moment we're authoring an application to serving that to your users. You know, opens a whole new barrier for Python.
Yeah.
There was another question.
No, silly question. Do you guys have any public documentation yet or no?
Do we have public documentation? You mean besides the source code?
Is this a troll question or that's legit question?
Training wheels, basically. I'm looking for training wheels.
Training wheels? Yeah.
We have the project documentation. It's been slowly evolving. I don't know, Tad, you just looked at.
It's about to go through a major transformation.
Exactly.
But if you go to PyScript.net and you go to the getting started, it has all the tag definitions and basically you can have that one and copy paste and put the HTML file in the script.
Yeah, we do have a lot to do there, but also, you know, contributions are welcome. We hope that the more the community uses it and see what we're missing in the docs, the community is also helping to improve them.
Yeah.
Yep.
You just triggered one thought. The last thing you said about mobile is that now everybody here can be a mobile developer because you can have WebView and then run mobile Python.
Yeah.
And WebView.
Yeah, the comment / question was, yeah, everyone here is now a mobile app developer. And the answer is yes.
Yeah.
And if you put stuff in there to do purchasing on like with some like, you know, crypto wallet or something, then you don't have to pay the iOS App Store tax, right? And at some point, if this stuff actually starts taking off, maybe the App Store locks that down, or iOS locks it down, but then maybe Android becomes more popular because you siloed the stuff. And if all the cool quirky apps being built by people are there, then that's where the platform will go. So we're absolutely about democratizing, creating fun, cool things, and having more and more of the younger generation not forced to see these things as just swipe attention hijacking machines, but actually as creative media.
Yeah, actually, funny story. My career highlight for my daughter was, "Hey, Dad, there's a PyScript store thing on TikTok. Like now you're famous." You know, like that was like the highlight for her. But on a more serious note, one interesting thing that has been happening in the mobile or the web, the web ecosystem is to try and bring the browser closer to the file system and the primitives in a secure way. So like using your camera, granting access to your storage and stuff like this with the proper security checks and stuff like that. So that also is very interesting as a story to become really a mobile developer, right? Like if you can access those assets in your phone or whatever tablet, that becomes super powerful.
And we can always polyfill it with a browser extension, right? If it's not quite there or whatever. So yeah, we'll figure out a way for sure. But definitely, yeah, it's very exciting. All right, I think we're at time.
Yeah,
great.
Thank you, Fabios. Thank you, Fabios. This was really